In this video, we are going to see how we can make sense of adding up infinitely many fractions. Hi, I'm Nick. Give me a follow for more unbridled mathematical adventures. So here we are asked to prove that the sum of k going from 1 all the way to infinity of 1 over k times the quantity k plus 3 is going to be equal to exactly 11/18. So what this means is we start with k being equal to 1. So if k is 1, what do we have? We have 1 over 1 times 1 plus 3. That's 1 over 1 times 4. So we have 1/4. But then this symbol here, capital sigma, means we're adding. So then we have plus, when k is equal to 2, we have 1 over 2 times 2 plus 3. So that's 1 over 2 times 5. So I guess we have 1/10. And then we have plus, when k is equal to 3, we have 3 plus 3, so 6 times 3, so I guess 1/18. And then plus, when k is 4, we can see that every fraction we have is going to be positive, and we're adding this forever. So we're adding positive numbers, positive fractions together forever, and we're told here that in the end of forever, this sum is supposed to be equal to exactly 11/18. That seems crazy. But to prove that this really is true, what we can do is begin by decomposing. So what we mean here by decomposing is we have this fraction. Just look at 1 over k times the quantity k plus 3. And we can say, well, that's going to be equal to two fractions. So if we add two fractions, we know if we have the same denominators, we can add the tops over that same bottom, right, over that same denominator. So what we can do is we can write some constant, some number a, over that first factor of k plus another constant k over the other linear factor of k plus 3. And then if we were to add these two fractions together, well, we would need the same bottom, right? We need a common denominator. So to do so, we can use the common denominator of the product of k times k plus 3. So to add these fractions together, well, we have a k here, a over k. We can multiply a over k by k plus 3 over k plus 3. And then for b over k plus 3, we multiply by k over k. So we're going to have a times the quantity k plus 3 and then plus b times k, and that's all going to be over times k times the quantity k plus 3. But if we have 1 over k times k plus 3 is equal to this over k times k plus 3, well, then we have 1 over something equals something else over that same something. Well, therefore, since the denominators, the bottoms, are equal, therefore the numerators must be equal as well. So we can set 1 be equal to a times the quantity k plus 3 plus bk. We can then just go ahead and distribute this a. So we have a times k is just a times k, and then a times 3 is 3 times a, and then we still have the bk. So we have 1 is equal to ak plus 3a plus bk, and then we have three terms here, ak, 3a, and bk. We can go ahead and factor out a k. So if we pull out a k from the ak and the bk, well, then we have a plus b times k, right? Because if that distributes, we have, well, ak plus bk. So yes, we have a plus b times k, and then still we have the plus 3a. But that's equal to 1. But wait a minute. Now we have 1 equals a plus b times k plus 3a. And, well, wait a minute. There's no k's at all. This is just equal to 1. So that must mean that a plus b must be 0, since there's no k's at all here. So if a plus b is equal to 0, that means that everything else, just 3a, must be equal to 1. So if 1 is equal to 3a, well, we just go ahead and divide by 3 and get that a is equal to 1/3. And if a is 1/3, then since a plus b is 0, b must be negative 1/3. So we would have 1 over k times k plus 3 would be equal to, well, again, a over k plus b over k plus 3. So a is, again, it's 1/3 over k plus a negative 1/3 over k plus 3. We can just go ahead and factor out a 1/3, and that's going to give us 1/3 times the quantity 1 over k minus 1 over k plus 3. So we have that our original sum, which is an infinite sum, right? An infinite sum or an infinite series is going to be equal to, well, we can go ahead and pull out the 1/3 in front of our sum. It's going to be equal to 1/3 times the sum, again, k going from 1 all the way to infinity, of 1 over k and then minus 1 over k plus 3. So if we go ahead and just put in some numbers for k, again, this means k is starting at 1 and it's going forever. But if k is 1, well, we have 1 over 1, which is just 1, and then minus 1 over 1 plus 3. So that's going to be just 1, or 1 over 1, minus 1/4. And then the sum here, the capital sigma, means we're adding. So plus, when k is 2, well, we'd have 1 over 2, and then we'd have minus 1 over 2 plus 3, so minus 1/5. And then plus, when k is 3, 1 over 3, and then minus 1 over 3 plus 3 is 6, so 1/3 minus 1/6. And then we'd have, when k is 4, 1 over 4, and then minus 1 over 4 plus 3, so minus 1 over 7. And we keep doing this forever. Then look what happens. Why is this called a telescoping series? Well, because it's like a telescope and it just collapses on itself. Because do you see what's happening? We have here a 1 minus 1/4, and then we have, well, the 1/2 minus 1/5, and then 1/3 minus 1/6, but then we have a 1/4 minus 1/7. So we're just adding all these terms, basically. The parentheses don't really matter, because we can think of this as 1 over 1, or 1 plus negative 1/4, plus 1/2, plus negative 1/5, plus 1/3, plus negative 1/6, and so on. So we're just adding fractions forever. We can add in any order that we want. So we can go ahead and take the negative 1/4 and add 1/4. Well, that goes to 0. And then what's going to be the next term? Well, the next term is when k is 5. So we'd have a 1/5. And then minus, I guess, 1 over 5 plus 3, so minus 1/8. But then we'd have a negative 1/5 and a 1/5. And then after that, we would have k being 6. So we would have a 1/6 to go along with this negative 1/6. And we can see that we keep going. Every single term is going to go to 0 except for the 1, the 1/2, and the 1/3. So this sum is equal to, it's equal to just 1 plus 1/2 plus 1/3. Everything else goes to 0. So if you add terms forever of 1 over k minus 1 over k plus 3, that is equal to just 1 plus 1/2 plus 1/3. Well, that's just 1 is 6 over 6, 1/2 is 3 over 6, and 1/3 is 2 over 6. But remember, our sum was equal to 1/3 times this whole thing. So it's just going to be 1/3 times, well, 6 over 6 plus 3 over 6 plus 2 over 6 is 11 over 6. So we have 1/3 times 11 over 6, which is 1 times 11 over 3 times 6 is, yes, 11 over 18. So yes, there we see it. It really is true. If we add this sum forever, again, k is 1, and then k is 2, and then k is 3, and then k is 4, and then k keeps going forever. Every single fraction that we add is going to be positive. Right? None of these fractions are going to be negative. Every single fraction is going to be positive, but obviously, yes, they are getting smaller, but they're positive forever. And if we add them up forever, in the end of forever, the answer is going to be equal to exactly 11/18. Wow. Calculator, take care. Again, make sure you give the Math Playground a follow for more unbridled mathematical adventures. Take care.